Page 3 of the review for the test. So we have to write functions given the information. So here we're given that we're supposed to write a cosine function. It has to have an amplitude of 5. It's supposed to have a period of 2 pi. And remember that 2 pi divided by the period would give us b. So here we've got 2 pi over 2 pi equals 1. So our b value is 1, which I'll omit. We have a shift to the left of 2 pi over 3, and there's no mention of a vertical shift. For the next one, we're told that we have to make a cotangent function. We're told that it's reflected over the x-axis, but we're not told anything about a stretch, so we don't need to put a number in front. We're told that the period is 8, so here's what that means. We know that pi, not 2 pi, pi over the period will give us b. So here that means that we've got pi over 8 is our b value. So right here we're going to write pi over 8. I don't see any mention, oh yeah, there's a shift. There's a shift of 1 to the right, so there'll be an x minus 1, and there is no vertical shift. Next we've got a cosecant function, so cosecant. There's no mention of a stretch of any kind, so I'm not going to put a number in front. There's also no mention of a reflection, so I don't need to make a negative. The period is pi, so you need to know for cosecant that 2 pi over the period equals b. So we're going to have 2 pi over pi, which equals 2. So b value is 2. We have no horizontal shift, but there is a vertical shift of up 2. In the next problem, we're told that we're supposed to make a cosine or sine function with the given information, and we know that there is a maximum at one point and a minimum at another. So I'm going to sketch this, and when we had a quiz on this, I don't know how people did this without sketching it, but yeah, I'd sketch it. So these are our 2 points. At pi over 4, it's at 5. And at pi over 2, it's at 1, and it has told us that this is a maximum and this is a minimum. So the easiest way to do this is just to assume the graph goes like this. It actually could do other things, which I won't get into here, because it doesn't say that these points are right next to each other, but we're going to assume that it goes from this max to that min. To make the graph, we're going to have to, or the equation from this graph, we need to know that the midline is at 3, because it's halfway between 1 and 5. You have to decide what kind of graph you want this to be. I'm going to pick our starting point as right here, which means that I'm choosing this to be a positive cosine function. So this is going to be y equals 2, amplitude is 2, cosine. I need to know what the period is. So if you look at this graph, from here to there, that is half a period. And so let's go ahead and figure out what this distance is. Well, yeah, sure, let's find this distance. So we want to know what that is. To determine that distance, we need to subtract pi over 2 and pi over 4. To subtract two fractions, we need a common denominator. So I'm going to make the first fraction over 4, which gives the difference as pi over 4. Now remember, this is only half of a cycle. To get a full cycle, we'd have to have this point as well, which means we have another pi over 4 right here. And if you add 2 pi's over 4 together, you get a period of 2 pi over 4 or pi over 2. But what we really need here is the b value. So to get b, remember that we do 2 pi divided by the period to get b, which means we're going to do 2 pi times 2 over pi. And if you multiply those together, you should get the value of 4. So our b value is now 4, because the pi's are going to cancel. We do have a horizontal shift. From my starting point, I am pi over 4 to the right, and I have a vertical shift of plus 3. This is not the only solution for this, depending on what you pick as your starting point, but that's my answer for where I started. For the next problem, same idea. We're given a maximum and a minimum point, so let me go ahead and graph this. We know that at pi, we've got a point at 10, so that's about here. And at 3 pi, we've got a point at here, which is 4. And, you know, it looks the same to me. Same type of problem. Halfway between 4 and 10 is 7. and our amplitude is 3. So once again, this is going to be a cosine curve. Y equals 3 cosine. Here, that distance is 2 pi. Since that's half a cycle, that implies that the period must be 4 pi. Once again, if we do 2 pi divided by the period, that'll give us the b value, which you should see as a half. So we got 1/2. We'll do x minus pi because I'm starting from here, so that's my horizontal shift, and it appears to be shifted up 7. For the last one on this page, we have similar information. So we're given that we have a maximum point at 6, 5. So here's 6, here's 5, and we have a minimum point at 2, 1. So that's what our graph roughly looks like. I'm going to decide to start from this point, which you don't have to, but I'm going to pick that. Our midline appears to be here at 3, and our amplitude is 2. So starting from that point, my amplitude is 2, but I need to put a negative in front of it because it's a reflected cosine curve. I'm going to write the word cosine. I need to figure out b. Remember that 2 pi, oh sorry, I've got to figure out the period first. So from here to there is a distance of 4. Because that's half a cycle, that means that the period must be 8. Once again, 2 pi divided by the period will give you the b value, which in this case is pi over 4. So we're going to write pi over 4 right here. Based on my starting point, I have a horizontal shift of 2 to the right and a vertical shift of plus 3. Once again, for all of these, there are lots of different answers. You could have written sine curves as well, but these were sort of the immediate answers that I came up with. And that's the end of page 3.